Go to the ant and learn. Consider its ways and become wise. Proverbs 6:6. That's kind of always been a thing that I always heard and learned as I grew up. And actually, I didn't really take it literally, but it does make quite a big difference in real life, actually. And I kind of found it fascinating how scientists actually used a ant to kind of find ways, better ways for salespeople to kind of move around and get around and quickly and easily and efficiently. And that kind of like little ants, they like work for solutions in real life problems. And I'm not really an expert on this, but with some reading up and all that, and with the contribution of Professor Dr. Thompson from NIC, a physics professor there, I kind of learned from him a little bit about the algorithm, how it helped out people with thinking about the postal service routes and all that. And kind of there's a lot of problems there, actually, if you think about it. There's which would be the shortest way, which would be the quickest, what would work best, and all that. And actually, the ant by watching ants, they found the best way, actually. It's kind of common sense, but I guess the ants had it before anyone ever around still. And here's a quote from back in 1975. The traveling salesman problem is considered today as one of the most interesting problems among the classical optimization problems. And that was from Lenstra and Kahn. And the ant algorithm is an effective model of solving traveling problems, I guess. And though easily observed, the ant colony is like probably the most complex and all that. It can lend great possibilities to solve many problems. The definition of an algorithm here is a set of rules to be followed in calculations or other problem-solving operations. Using an ant colony optimization algorithm is finding good paths through graphs, kind of like finding some point off of the y-axis to the x-axis, some point off the x-axis, kind of finding the straightest route. And I remember back when I learned that the straightest route is a line between 2 points. An exact algorithm would assume that the distance and cost of travel would be the same going from both directions and all that. And yeah, if we look at the colony system a little bit here, it's kind of like very precise. The ants, the one goes out and it goes around and finds them, and it's called that. When the one ant just goes by itself, they call it a local pheromone update, and that's when it goes out and comes. When it's coming back, it's dropping little spots of pheromone, which is like a chemical behavior altering agent, and it just drops those along the way. And when the next ant comes by, it just drops some more and just makes that line more distinct, and they kind of follow that path back and forth, and each ant drops a little more, and that line just gets stronger and stronger, and they know how to get there and back. And what I mentioned there, the other one is a global pheromone update, when all the ants kind of finish with that one spot, when they've all got that food cleaned out or whatever, and they've got all back at the nest. They call that a global pheromone update, and those are kind of the two rules. The global pheromone update and the local pheromone update are kind of the two rules to the ant algorithm. And kind of like what struck me is nature teaches us like pretty valuable lessons there, and it kind of like here it impacts a lot, just that little ant, and it impacts the way that salesmen or mail service carriers just go around and get their job done and all that. If it's something to do with travel, most of them just are impacted by just that little ant, probably. And I hope today that you learned how the tiniest things in nature we can adapt to be more effective in what we do and all that. And just a little thought I'd like to leave you with is, well, we work as a unit and kind of help each other along the way, and kind of like ants do. They kind of leave a path for someone else to follow. Thank you.